Lecture 7: Transforming ER Model to Relational Model. Hello everyone and welcome back to our DBMS series. In this video, we will discuss how to transform an ER model into relational model. Both ER model and relational models represent real-world entities in logical manner because they follow similar design principles. We can convert an ER diagram into relational database design. This process helps us create tables from an ER diagram and define their relationship. By the end of this video, we will understand how entities, attributes, and relationships are mapped into relational tables. What is ER to relational model conversion? The process of converting an ER diagram into tables is necessary for implementing the database in a relational database management system like MySQL, Oracle. So why is this important transformation? It provides a structured format to store data. It ensures data integrity and eliminates redundancy. It establishes relationship between entities using foreign keys. Now let's go to step by step on how different ER diagram components are transformed into relational tables. First, strong entity. A strong entity is independent entity that has primary key. It becomes an individual table in relational model. The primary key of the entity becomes the primary key of the table. Foreign key are added to establish relationship. For example, for an employee entity with attributes employee ID is a primary key, name, age, and salary we create. Weak entity. Weak entity depends on strong entity for its existence. It gets a separate table. The primary key of its corresponding strong entity is added as a foreign key. The primary key of weak entity is composite key. Example, if dependent is a weak entity related to employee, then employee ID is primary key, name, age, salary, attributes. Depend department ID, employee ID as a foreign key. Department name. Relationship primary key is dependent equal to department ID and employee ID. Single valid attributes. These are stored as column in a table. For example, the employee entity with attributes employee ID, name, and age has employee ID is primary key, name and age attributes order. For composite attribute, each sub-attribute is stored as individual column. The main attribute is ignored. For example, if an entity has address which has street, city, zip as a composite attribute, then the customer ID is primary key, street, city, zip. Instead of storing address as a single column, we break into multiple attributes. Next, multi-valued attributes. A new table is created for each multi-value attribute. The primary key of the original entity becomes a foreign key in the new table. The new table's primary key is composite key. Sixth, derived attributes. Derived attributes are not stored in a table because they can be calculated. Example, if age is derived from date of birth, we store date of birth but not age. Next, generalization. Generalization is when two or more entities share common attributes and we create a higher level entity. Method 1. Superclass table plus subclass table. A table for the higher level entity is superclass is created. Separate tables are created for each superclass that includes primary key of the superclass, additional attributes specific to the subclass. Example, if we generalize accounts into saving account and current account, we create like account number will be primary key, balance is the attribute, then saving account number is primary key, interest rate, daily withdrawal limits, then current account primary key, overdraft amount per transaction changes. Method 2, no superclass table. It is also known as flattened approach. Superclass attributes are duplicated in subclass tables. Drawback of method 2 is that data redundancy. Example, balance is stored twice. Can't represent account that don't belong to any subclass. Understanding the aggregation. When a relationship involves another relationship, we use aggregation. A table is created for the relationship. It includes primary keys of participating entities and any descriptive attributes. For example, if a project uses suppliers and we track supply content, we create project project ID as primary key, project name, supply ID is primary key, supplier name, contract project ID as a foreign key, supplier ID as foreign key, contract details. Foreign key of contract is project ID, supply ID. Conclusion. That's all for this session of ER relation model conversion. In conclusion, transformation of an ER into relational schema is a crucial skill for database design. We explored two main methods, the superclass subclass approach and the no superclass approach, along with the concept of aggregation. Each method has its unique advantage and scenario of application. Mastering these techniques will enhance your proficiency in database management. We encourage you to apply this concept in your upcoming projects. That's all for this session. I hope this lecture gave you a clear understanding of how to transfer an ER diagram into relational schema. Thank you.